Hi everyone, and welcome to the channel Without a Wire, where we explore everything a smart home can throw at you. In today's video, we'll play around and explore some LED solutions. I've never really been a fan of LEDs, but let's see how it goes. Hi everyone, and welcome back. So today I need to solve a problem in my kitchen to put some light into a dark corner over my oven and sink. But in doing that, I can't put in any LED strip there because LEDs are normally not waterproof. And working at the zinc and with the stove, there's a lot of steam and a lot of heat. So I was looking for an LED strip that is heat resistant and waterproof. So I found this strip online. It's made up of a silicone compound of some sort, and it's even fire retardant, which means this is the perfect LED to put in there, and it gives me a light angle of about 120 degrees. The problem with this is it didn't come with a power supply. Now, because this light came without a power supply, it also came without a connection. So I had to go out and I had to buy this DC block just to connect these two wires, the black and the red, to be able to connect to the power supply. And reading up on this, it says that you need a 12 volt and 0.8 amp per meter. And since this is a 5 meter strip, I went out and I bought a 12 volt 5 amp power supply. And believe it or not, if you buy this LED strip with its own power supply, it will cost you about 140% more. So I paid about 60% of the price for this LED strip without a power supply and just sourcing a separate power supply with it. That price also includes my sensors and making it smart with a Sonoff Smart Basic Wi-Fi switch. So making it smart is quite easy. All I do is I just put in a little Sonoff Basic Wi-Fi switch in the power line. But what I've also done is I prepared a cable that will fit directly into my UPS. I've got an inline UPS nearby, which means that I would also have some lighting when we have a power outage or when there's load shedding. The other problem I needed to solve is how to switch this light on and off, because I wanted to automate it. So in order to automate it, I went through quite a few solutions, contact sensors, motion sensors, all of which is not giving me what I need. So sitting back and thinking about the problem, the solution is heat, because when I use the oven produces heat. When I use the zinc to wash dishes, I use warm water. So I thought, why not use a temperature sensor? So I bought two of these Sonoff Temperature sensors, which runs off Zigbee, and I can connect them directly to my Amazon Echo Show 10, which means that I can then write routines for these. So in order to establish where to put these sensors, I went through a series of tests. The zinc was quite easy. I just installed it with some double-sided tape or press stick underneath the zinc. And whenever I fill the zinc with hot water, the temperature sensor will pick up the rise in temperature, and it will then trigger the Sonoff switch to switch on or off, giving some power through to the LED. The oven, on the other hand, was a bit more complicated because it produces more heat. So you need to put the sensor in a place where it will pick up the heat, but where it will not damage the sensor. So first, just to test the sensor, I put it onto the oven switch right above the oven, just to see if it produces enough heat to increase the temperature on the sensor to trigger the lights. It worked, but in this position, the sensor will be subject to a lot of heat and a lot of steam, which will damage the sensor over time. The second option I tried was underneath the hob. So I put it there and I switched on the oven, and it is so isolated there that the sensor hardly picks up the rising temperature, which means by the time I reach my target temperature, the light goes on and I'm finished cooking. So putting it underneath the hob was not a great idea and not the ideal placement for the switch. So I thought, since I had it on the oven switch, can I not put it in behind the switch? Because it still exposes to heat, but the shield on the front of the switch is also heat resistant. And there's enough space inside the wall behind the switch plate for the sensor to fit in. So I loosened the plate and I took out the switch and I slipped this in behind the switch and started testing it. It worked perfectly. So it will switch on the light and it will switch off the light when it cools down. So after I installed the sensor in the wall behind the cover plate of the oven's emergency cutoff, I started testing it. So the first thing I did was to write down the resting temperatures of both the zinc and the oven over a couple of days. I found that the resting temperature was between 65 and 67 degrees Fahrenheit. So that was my starting point. The other problem I had when I first started testing these sensors and writing routines for them in the Alexa app was that the routines allow you to choose between degrees Celsius and degrees Fahrenheit. But when you start running these routines, nothing happens. So I went into the device settings onto the device and I found that there's no setting to set these in the Alexa app as to what you want to feed into the app, whether it's Fahrenheit or metric. What I did is I changed the routines to Fahrenheit after I took the readings over a couple of days, and I started working from there. So the zinc was easy. I put it underneath the zinc and I put in some water and the temperature started rising, and I found that the ideal trigger for both the zinc and the oven, in fact, was 68 degrees Fahrenheit. And once these sensors start cooling off, I put the off trigger at 69 degrees Fahrenheit. Tested it for a while with my kitchen lights, which is also smart lights, just to see if it works, and it works beautifully. So now that I talked you through all the obstacles that I faced in setting this up, let's go install this and see what it looks like and how it works. Okay, so the light is installed now. Took a little trouble, but it's connected. It's running on the UPS, and I've already set up the Sonoff Basic Wi-Fi switch in my app. So it's already connected to my Amazon account. Let's see if it works. Alexa, switch on the counter. There you go. Now let's see how it works with the two different temperature sensors. Okay, let's start with the zinc. The resting temperature of the temperature sensor is now 66.8 Fahrenheit. Let's put in some hot water and see what happens. Just finished putting in the water. So this is normally the time it will take me to start doing the dishes. And the temperature already started going up. It's about to hit 68 Fahrenheit. And then the light should go on. And there you go. As you can see, I'm done with the dishes, and the temperature on the zinc is now 79.1 Fahrenheit. And let's see when it cools down. Temperature triggers is actually 69 to switch on the lights and 68 to switch it off. The switch off temperature has to be lower than the switch on temperature. So we'll see the temperature is dropping now, and once it reaches 68 or below, it will switch off the light. There you go. Once it goes below 68, it will switch the light off automatically. Now let's start with the oven. The resting temperature for the oven is now 66.6 Fahrenheit. I'm just going to switch on the plate at the back here, and we'll see what it does to the temperature. The oven does take a little longer to trigger the temperature sensor, but that's okay because it's a longer routine spending time behind the oven cooking. So I don't need the light to switch on instantaneously, but I need the light to be on by the time I start working behind the oven. It takes about 7.5 minutes for the temperature to start rising, but when it starts rising, it rises quite quickly. And when it reaches 69 degrees Fahrenheit, it will switch on the light. My experience with the heat increase on the oven or on the stove is when I have cookware on the plates, the heat disperses to the plug quicker and the temperature rises quicker. Because this is over an open plate, the temperature is not rising as fast on the switch as it normally does with cookware on the stove. There you go. Reached 69.4 and the light switched on. I'm going to switch off everything, wait for it to cool down, and then I'm going to test the off routine, or the routine that switches the LED light off. So it does take quite a while for this sensor on the oven to cool down, but this is not the only mechanism to switch off the light. You also have voice commands, and you can switch it off in the Alexa app, or you can switch it off in the EWLink app. So you don't have to wait for it to cool down to switch off. Unless you forget, it will switch off automatically. So the switch off on the oven sensor is mostly a fail-safe, but not really an immediate trigger like with the zinc that heats up and cools down quite quickly. There it just went under 68 to 67.2 and it switched off the light. So yeah, like I said, this is more fail-safe. There you can rather use voice commands or the apps available to you to switch off the light when you don't need it anymore. Thanks everyone for watching. And if you like this video, please give it a like, and also hit subscribe and the bell icon if you want to get notifications of future content. If you would want to contribute to this channel, you can make a once-off donation to my PayPal, or you can join the Patreon campaign. Both links are in the description below. I would also leave some links as to where you can find all these devices that I worked with today in the link in the description below, so you can go check it out there. Thanks so much for watching, and see you in the next video.